Chapter 9 is going to be an introduction to trigonometry, and the first section in Chapter 9 is talking about right triangle trigonometry. A lot of this may seem familiar because you did study this in geometry, and we're talking about our trigonometric functions or our trigonometric ratios, and that would be sine, cosine, and tangent. There's actually 6 trig functions that we talk about in the upper level classes. You have sine, cosine, and tangent. Then you also have the reciprocal of those 3 functions. The reciprocal of sine is called cosecant. The reciprocal of cosine is called secant, and the reciprocal of tangent is called cotangent. Now, just to remind you, the parts of a right triangle are you have the two sides that form the right angle, and those sides are called the legs. The third side, which is also the longest side, and that is always directly across from the right angle, is called the hypotenuse. And the hypotenuse is always going to be the longest side of a right triangle. Now, the trig ratios are made up of, or the trig functions are made up of a ratio of 2 sides. And the sides are always in reference to a particular angle. A lot of times in geometry and in trigonometry, we will use Greek letters to represent some of our angles. This Greek letter, which looks like an O with a line through it, is actually the Greek letter theta. And a lot of times in trigonometry, we'll use the Greek letter theta to represent an angle. So when you're looking at a particular angle, how the sides kind of orient themselves is, the side all the way across that you would have to cut through the triangle is the opposite side. The leg that is right next to or is connected to that angle is the adjacent side or the adjacent leg. And the hypotenuse is always the side that is directly across from the right angle. It will always be the longest side. And these 6 trig functions are just made up of a ratio of 2 of the sides. Sine is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. Tangent is the opposite leg over the adjacent leg. If you look at cosecant, and CSC is the abbreviation for cosecant, SEC is the abbreviation for secant, and COT is the abbreviation for cotangent, you will notice that they are just the reciprocal of the trig function that is above it. Cosecant is hypotenuse over opposite, which is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So another way you can kind of think about it is the cosecant is the reciprocal of, or is 1 over sine. Secant is 1 over cosine, and cotangent is 1 over tangent. But the easiest way to remember is that these are the reciprocal functions. Now, for the first part of this, what we're going to be doing is we're going to be given some sides of a right triangle, and we're going to come up with those ratios for that particular angle. So if you look at this picture right here, it says evaluate the 6 trigonometric functions of the angle theta. So when they tell you to look at this angle theta, it's like that is your starting point or your point of reference. So this is the angle that we are starting from. Now notice that here we have sides of 5 and 12, and both of those are the legs, but they didn't give us the hypotenuse. Well, please remember back to geometry that anytime you have 2 of the 3 sides of a right triangle, we have a handy-dandy formula called the Pythagorean theorem that will allow you to solve for the missing side. And the Pythagorean theorem is a squared plus b squared equals c squared. A and b, doesn't matter which one is which, but they do have to be the legs, and c has to be the hypotenuse. And so we can use this to find out our hypotenuse before we start. 5 squared plus 12 squared will be our hypotenuse squared. 25 plus 144. When you add those together, you get 169. And then just like in our last unit, if we want to get rid of the squared, when we square root both sides, we will get that side C is 13. Now we have enough information to calculate the 6 trig functions. The sine of theta, all right, so from our starting point, is the opposite side over the hypotenuse, 12 over 13. I would immediately go and do the cosecant function, and that is just going to be the reciprocal, or 13 over 12. cosine. Cosine is the adjacent leg to that angle over the hypotenuse, or 5 over 13. Therefore, its reciprocal function, which is secant, has to be 13 over 5. And then last is our tangent function, and tangent is the opposite leg over the adjacent leg, 12 over 5. And so my reciprocal function, cotangent, will have to be 5 over 12. And there are your 6 trig functions. You do not need to change them to a decimal. If your fractions would happen to reduce, go ahead and reduce your fractions, but these will not. So just leave them as they are, and you have evaluated your 6 trig functions. Now, one thing to point out, notice over here I have this place over here that I'm going to start including in all the notes. Should you have a question on something that you see in one of the examples, pause the video, write down your question, and go on to the next example, and then we will answer these questions in class tomorrow. Let's look at one more example that's similar. Let's look at example 2. This one says, in a right triangle, theta is an acute angle, and the sine of theta is 4 over 7. Evaluate the other 5 trigonometric functions. Well, the one thing that really makes trigonometry, just like geometry, much easier is if you draw a picture. So here's our right triangle. It really doesn't matter which of your 2 acute angles is theta. I'm just going to pick this one. But what I do know is that since they gave me the sine ratio and sine is the opposite leg over the hypotenuse, I do know that since I picked this as theta, the opposite leg has to be the 4 and the hypotenuse has to be the 7. And so what I don't know is this side right here. And you can label it X, you can label it A, it doesn't matter. But let's use the Pythagorean theorem to solve for that missing side first. So what I do know is that x squared plus 4 squared will equal my hypotenuse squared. So x squared plus 16 equals 49. I would need to subtract 16, and that will get me x squared equals 33. And then when I square root both sides, I will get x equals the square root of 33. Now that is not going to simplify. It's also not going to work out nice. We're just going to leave it like that. It's perfectly fine. It's better to leave something in radical form than to change it to a decimal and then have decimals inside of a fraction. Okay? So just leave it as the square root of 33. If you happen to have something like the square root of 75 that can simplify like we did in the last unit, go ahead and simplify it. But now that we have all 3 sides, we can evaluate our other 5 trig functions. We already know what the sine is. We can evaluate our other 5 trig functions because we have all 3 sides. Now, since I know the sine function, I'm going to immediately write down that cosecant is going to be 7 over 4, because remember, sine and cosecant are reciprocals. Let's go ahead and find cosine. Cosine is the adjacent side over the hypotenuse, and so for our triangle, that'll be the square root of 33 over 7. And so then I'll immediately do secant. Secant will be 7 over the square root of 33, but if you remember from the last unit, you shouldn't leave a square root in the bottom. The simplified answer will be 7 square root of 33 over 33. And again, if you don't remember how I calculated that, write down that question in this box, and we will go over that in class tomorrow. Tangent is the opposite leg over the adjacent leg, 4 over square root of 33, which will be 4 square root of 33 over 33 when you simplify it. Cotangent will be the reciprocal of this, which is the square root of 33 over 4. But now you have the other 5 trig functions. All you have to find any of the 6 trig functions are the 3 sides of a right triangle, and then you can always figure them out based on their angle. Now, tomorrow in class, we will answer the questions that you have written in the box. The you try problems will be the problems that we do in class together. just to kind of go over and clarify any questions, concerns, things like that you have. One thing I do want to point out, and we will mostly just work with decimal values off the calculator, but some of your special angles, 30, 45, and 60, these are the ones that are more commonly used. As you get into the upper level classes, we will start to ask for exact answers. And so these are what some of the exact answers of the more common angles will look like. For our introduction, though, we will be using the calculator quite a bit.